Hello everyone, this is Maniramakrishna. So today we talk about the topics called control system for the third year first semester students. Okay, so first we'll talk about the why we need the control system. Okay, so what is the purpose of the control system to for the electrical and electronic students? Okay, what is the need? Okay, so not only for the control system, so this subject is deal with the different branches, that is for electrical and electronic students as well as instrumentation students. Okay, this is the main course for the electrical, electronics as well as instrumentation students also. Okay, so let's talk about the why we require, okay, in the control system subject for the electrical students, electronic students and instrumentation students. Okay, so these subjects, okay, so what these having subjects and what is the purpose we require to study? Okay, what is the need and next purpose of the study? Okay, so first we'll talk about the here what are the topics we have. Okay, what is the system? Okay, so why we require in the real time? Okay, so how this subject is useful for the engineering students? Okay, why, where we can apply in this session? Okay, let's start with the some small example. As we know, suppose in the summer season. Okay, so we'll talk about the we'll talk about the one person. Okay, so students are, okay, so in the summer season they will having the play the games in the outside. Okay, due to the summer heat it will be temperature should be high at the outside, as we know that's coming. Okay, so whenever the temperature is high, so when we go to the inside to the home, okay, when we go to the inside to the home, what will happen? We feel too much heat. Okay, even though how much fan is there? Okay, so we have in the India we have the most of the fans, 3 blades and 4 blades fan is there. Okay, how much turn we am the fan? Okay, airflow will be there, right? So even though small airflow is that we cannot be cool our butt. So what we'll do, we will increase the fan speed. Okay, we will increase the fan speed. So why we will increasing? To increasing the flow, airflow in the room. So here in real time, so if it is increasing and decreasing, so that is a one type of the control is there. Okay, so that is a one type of the control. So this is the one system. So here is the system is there, the fan is the system, here is the control. So that is an open control system. There is no feedback is not there for controlling the fan. Just we are controlling the fan with the switching on and turning the dim. That's it. So here is one of the example. Next we will talk about the another example. Okay. So we will talk about the car. Okay. So we will talk about the car. So when we running the car, okay, here we having the one car have, so it will goes to the in the road. Okay, so whenever the roads is there, so we need to, if it is slope is there, if it is road is having slope, so we need to decrease the speed. If it is slope is there, okay, whenever the height is there, so we need to push the accelerator. So we need to push the accelerator, then only speed will be increased. Whenever the too much slope is there, at that time we will decrease the speed. So we are controlling the that four wheels with the acceleration. Okay, whatever the accelerator is, that we are controlling that speed. So this is the one type of the control. So how we need to control? So based upon our vision. So we are seeing the whatever the driver is there, the driver seeing the road. Is it slope is there or height is there? Is there an obstacle is there? So whenever the sudden obstacle comes for the driver, so what will do? You need to press the brake. Same thing here in the real time. So different types of systems are there. So we need to control that system in the systematic way. So why, how much desiredness is there? Okay, whatever the operating point is there, whatever the maintenance. Okay, so we need to controlling the device in a such a way that we need to operating in it. So we need to control the devices as much of as operating point as well as our desired level of operation to conduct this smoothly operation. Okay. So in this one, so here we'll talk about the first introduction. Okay, so here things that, so whatever the equipment system, okay, in all equipments, like we'll having the coming to the, so these subject is deal with the all types of subject. Okay, so it is including the machines. Okay, so as we know, DC motor, so DC motor, and as well as turbines, alternator. Okay, so all we need to control the speed. Okay, so by controlling the speed only we can generate. So how we are going to control in the terms of the powerhouse. So here the governing system is there. Based on the governing system, and the speed will be controlled through the water flow. How much water flow is based on that speed is governed by system. Here in the real time applications, this is one of the example for next. So here in automatic control system, okay, so he will take the one of automatic controls. So as we know that we having the in our home one fridge will be there for the cooling. Right? In summer season, most of the persons will use for the cooling. Okay, so whatever the equipments are there in the refrigerator, we place the all items into. Okay, here if it is refrigerator is there, so here refrigerator having a different conditions. So if it is want to increase the speed, okay, so based upon the how much weight you place, okay, so how much weight you are placed, based on that it will be generate the that much of cooling. Okay, that's one of the application. So how if you not control that cooling, so it will total cooling. Okay, gas will be leaked from it, and total all items in the refrigerator. So that will be what will happen. So total all equipments will be ice, right? So that is the one. So that is the controller. If this fail, like that will happen. See, that is the one of the controller. Okay. So this is one of the application. So this is the one application we can. So this is the one. Next. So here, how we are, this subject is this. Okay. How this subject is deals with the to control the equipments. So how we can control the equipments to the math. So first we'll talk about why the subject having the mathematics modeling, and why we require the prerequisite of matrix algebra and calculus, apply multivariable calculus, numerical methods, and complex variables, and fundamental physics law. That thing we must know why we need the. Okay, today in this session, why we require the maths for knowing the control system, that will talk about. Only this line only we will talk about the today. Okay, so first, why we require the maths in the control system. First thing, okay, first thing we'll talk about here, maths is required for the to understand the control system. We require the maths. Okay, why we require? Okay, let's take the one small example of our system. Okay, here in the control system, what will happening actually? So why we will go to that? Okay, so suppose here we having the equipment. Okay, so we having the one motor and generator set is there. Okay, so this motor and generator set it's running. So what will it? So generator is generate the three-phase supply. That will. So here motor is that is, so prime mover as you are using as a DC motor as a prime mover you are using to rotate the generator. Okay, so here for to generate the power supply, three-phase supply, so we require the, so here in two pole machine, okay, in two pole machine, how much speed is? So if it is we need to get the power supply, so based upon the system speed, so here whatever it's the motor speed is there, that should be matched. Okay, so generator should run at the maximum Okay, whatever the rated speed is. So if it is, suppose if we consider the 1500 rpm of the generator speed. So if it is motor runs at the 900 rpm, so what will happen? The power generation is reduced. So we need to increase the power generation. Means what we need to do? We need to run the motor at the rated speed. That's the one of the example. So if it is less speed is there, what will happen? The voltage generation is reduced. If it is exceeds the speed, what will it will generate the, okay. So that should be controlled by the as much as based upon the, our load requirement. So we should not be exceed, we should not be decrease. It should be maintain the corresponding speed to generate the power supply. That's we need to do. That's it. So to that we require the, so how much speed is there? Okay, for the motor and generator analog unit. Okay, so to do that, so first these we can not do in the real time directly. Okay, so we cannot do directly to place the motor and generator, and it will be huge cost with it. Okay, so for that one, what we'll do first in the generation, we will do the mathematics. Okay, so here whatever the system is there. Okay, so first here our motor setup and generator setup. So motor input what we are giving. Okay, suppose is the prime mover. Okay, so prime mover what we are giving, so if it is water flow, if it is concept of the hydro power plant, we are giving the kinetic energy. Okay, so kinetic energy is given. So motor speed, how is it? Okay, so generator is the giving the electrical power. So this motor we will convert to the system. Okay, so we will convert to the motor or prime mover. Okay, prime mover all equipments into mathematical model. So that will go to the all mathematical model. So how we will do mathematical model? So here all motor and generator sets will have the mechanical and electrical component. That's resistor, inductor, right. So resistor, inductors, all things we are converted to the in the mathematical model. So in the mathematical model, so first after converting the physics model, okay, by using the physical part, means whatever the ratios there, like how much winding is there, how much ratings of the resistance, inductance, capacitance, okay, as well as how much length is there, width is there, diameters. That's all conversions will do. Okay, so that's why we require the fundamental physics law. Okay, to convert the system, physical system into mathematical model, we require the physics law. Okay, each equipment, so how we need to cut. So diameter is there, what is the diameter, length, width, that will all be required physics law. Okay, next we'll talk about the why we require the algebraic support. So here in the system, okay, so here we having the system is there, matrix algebra. Okay, why we require the physical ability? So here why we require calculus, numerical method, complex values. Okay, here system is, okay, we build the system, how it will run, so that we need to check. So here not only will be, okay, so we require the different mathematics analysis will require for after conversioning the physical system into mathematical model. Okay, so addition, subtraction, next integration, differentiation, okay, and trigonometry. So all things we require to conversion from physical model to mathematical model. Okay, so that's why we require the each mass of the, okay, so all things we require to conversion, that is whatever the physical model is there. Okay, so physical model to mathematical model. Okay, to convert the physical model to mathematical model, we require the these prerequisites, that is physicals, fundamental physical law, mass, algebra, calculus, multivariable calculus, numerical methods, and complex math. Okay, that's why we require these. Means to conversion, that is whatever the physical equipment is there. If you want to do that to mathematical model, then we require these all things. Okay, this is about this session. In the next session, so first we'll talk about the slides. So these are the things we have. Next we'll talk about what are the core subject. Here, so here the core objective are the here to understand the mathematical modeling of the physical system. So here whatever the equipment is there, how we need to convert the physical system to mathematical model. Means we need to here whatever the physical model. Okay, so first principle based mean we'll talk about. So the first physical input is so whatever the physical system is there, that will convert to the mathematical model. Okay, suppose here we having the system, that is suppose we having the system BLDC motor. So here BLDC motor we have. Okay, so in the BLDC motor we having the rotor as well as stator is there. Okay, so this motor and is there, so it will have the stator as well as rotor. So that will all include the resistor and inductors. Okay, that resistor and inductors what will have in, so that is the electrical components. Okay, and all equipments in the is there. So these system physical system too will convert to the electrical. Okay, that is inductor and resistor model will convert. Then this will be converted to the mathematical model. Okay, so that mathematical model we derive, then we will make as a one system, either first order system, second order system, or transfer function model system, or FOPDT, like. Okay, we'll convert and then we'll control that. So that's why we require this. That is conversion, that is mathematical conversion. Next, comprehensive present dynamic system through input output models into transfer. Okay, so state weight representation. Okay, to represent the system means suppose here is the BLDC motors there, or normal fan is there, or motor generator set is there. So we have the representation of system, we have the different. Okay, so we can having the different systems. So before going to system, we will having the first thing is there. So as you know, that is open loop system, closed loop system. Apart from that, so based upon the inputs, if it having single input, single output. Suppose here BLDC motor is there, that's a single input, single output. Means we'll give the electrical supply, it will give the mechanical output. That is a single input and single output. Okay, so that is one. So if it is a single input, multi output system also will be there. Okay, and multi input, multi output system also there. Okay, so here multi input, multi output system we will having the distillation column. Okay, so in the distillation column we crude oil. Okay, best example is a crude oil distillation column. So in the crude oil distillation column we will having the different types of tags. Okay, here we insert to the petroleum, so it will convert to the different outputs. Okay, this is the one single input to the multi output. Okay, or multi input to multi. So depends on how many inputs are given and how many outputs you are getting. That's one thing. And another multi input, that is so two input two output system. Here RO plant. Okay, reverse osmosis system. So that will have the input will give in a different way. Speed also will give, means through the pumps will supply water. Okay, and how much water quantity is there. So that based. So how we are giving. So one of the two input output is the RO plant. Here BLD is a single input, single output. Distillation column is the multi input, multi output system. Okay, and water and ethanol power plants. Okay, different distillation columns are there, and CSTR plants are there. Okay, so these all systems will comes under single multi-variable system. Okay, multi-input, multi-output, or two input, two outputs, three inputs, two output system will have. Okay, that's a different scenario about the systems. Okay, single input, single output, multi-input, multi-output system. So this we require the to whatever the system are there. So we require the one controller. That controller it mainly will talk about in this whole syllabus. We'll talk about the PID, either PI controller, PD controller, PID controller. Okay. So here we can use as I. Okay, we cannot use D as a separate controller. So either we can use the P as a separate controller, PI separate controller, and PID. So you cannot use a D as a not separate controller. Okay, that each performance controller quantities we can learn here. This is the first introduction. So in the next session we'll talk about the modeling system and this. So we'll start this session. So here in the whole subject, so what we are going to learn? Thing is that first in the whole subject, okay, in the 2 lines we'll talk what we are going to learn from this subject, why we required from electrical, electronics and instrumentation students. So in the 2 lines we'll talk. Okay, first thing we have the different types of systems are there to control the system. Okay, to control the system. If it is instrumentation people is there, if having the processes, so to control the process one. If we talk about the electrical system, so we have the power system. Okay, in the power line controlling are there, electrical machines are there. Okay, if we talk about the electronic students, so electronic circuits are there, antennas are waves there. Okay, that we need to control the equipment, embedded systems. So to control each equipment, we require the controlling block. So that's why we require this system. Okay, that's why we require to know about what is the basics, fundamentals of each system. As well as apart from this that, so we must know about the signal and system, about small knowledge required for learning these controlling. Okay, so one is the why required. So in this whole control system, we are going to learn. So what is the system? What is the system? Why we need the controlling? Okay. So next, how to control the equipment and how to physical system to mathematical modeling. Okay. So if the physical system is given, so how to convert the mathematical model and how to control by using P, PI, PID controlling devices. Okay, for this one we require the mathematical modeling and block diagram reduction, signal flow graphs. Okay, and to so to check their stability, we require the stability point of view board plots. So stability range. Okay, so to check the stability, time response, next frequency response plots. So this all for the stability point of view. Okay, to represent the system, different types of systems are there. Okay, so that system we are going to learn each. Okay, so how this is about all about introduction about the control system. Hope this video might like to you. So if it is like you, so put your comments in the down and check if any required comments. Okay, if you any doubt here, you can place in the comment box. We will check and based upon we'll give the true inputs. Thank you. Have a nice day.